So hello friends, welcome back once again in the next lecture of the React Native. And in my previous lecture, we have discussed the React Native old architecture. So this is the diagram of the old React Native architecture we used before React Native 0.68. So this old architecture I have described in my previous lectures. So friend, if you did not watch my previous lecture of the old React Native architecture, I have given the link in the description box. So you can check from the description box, because before understanding the React Native new architecture, we should be knowledge of the old React Native architecture. So because many things we used in old React Native architecture, we will also used in React Native new architecture. In this lecture, I will describe what's the problem of the old React Native architecture and what is the difference between the old and the new React Native architecture, and also describe what is the benefits of the new architecture. So first discuss what is the problem of the old architecture.
So this diagram we have used in my previous lecture of the old architecture. So before understanding the problem of the architecture, a brief introduction of the old architecture. So here React is where developer is working on the JavaScript, and here JavaScript thread used by JavaScript engine to run the JS bundle. A JavaScript bundle is actually a tool that puts your code and all its dependency in one JavaScript file. And here JavaScript engine is actually a computer program that executes JavaScript code and convert into computer understandable language. Actually, a JavaScript thread is where all JavaScript code is executed. A JavaScript thread is where all the JavaScript code is read and compiled, and where most of the business logic of the app happens. So second is the native UI or native main threads. So this is the primary thread and perform synchronous operations. So it is the main thread and it is responsible for user interaction and rendering UI on the screen of a device. So it is the same thread that is running in every fully natively built application, you can say. Third is yoga, or you can say the layered thread or background thread. So it is used to decide the layout of element in UI before rendering. So actually it works along with layout engine like yoga, you can say, and which is used to calculate the UI element positions. So the most important part of the old React Native architecture is bridge. So it allows us to exchange information between the JavaScript and native layer through JSON message. The first problem we face with old React Native architecture is bridge. So bridge is asynchronous, and sometime while exchanging information in asynchronous way with very fast bridge, so sometime it is not enough and synchronous way would be better. So actually bridge leads to slow transfer rate and unnecessary copying of data. It means that, for example, if React elementary node happens to be an image, then consequent node of React shadow tree will also be an image. But this data will have to be duplicated and stored separately in both the nodes. So friend, all these things of the architecture is working under the hood and we cannot see it, but actually it is the concept of the React Native, actually how it works. We will also discuss this point in next few minutes. So when we work with React rendering, so first of all React element tree is created, and after the React shadow tree will be also created, and React shadow tree is based on the React element tree. So here is the example of the image. So first of all, the image React element tree created in React and React shadow tree will be created in React Native. So this data will be duplicated and is stored in separate in both nodes. So it will be stored in JavaScript thread and will also be stored in native UI threads, and the data of the image will be duplicated in both nodes. So it is the drawback and problem of the old architecture. So since the JavaScript and UI thread not in sync, so when JavaScript thread and native UI thread communicate with each other, so they communicate with asynchronous way. So they are not in sync. So there are certain use cases when your app can seem laggy as it drop frames. When you have big list of items and start scrolling really fast, you might see blank screen before rest of items are shown. So friend, it means that when you have a big list of items and when you scrolling very fast, so sometimes in asynchronous way you can see the blank screen and rest items are shown. So this is the problem because we are working in old architecture in asynchronous way. So UI and JS thread is not sync. So this is the drawback of the old architecture. So performance problem when running complex animations. So when we work on the complex animations where we work with animation related work and very complex animation we want to show, we can face the problem of performance. Slow navigation transition occur because of timeout or animation. So it is the also another problem of the old architecture because navigation is also not work according to our expectation. So the goal of the new architecture is to solve some of the issues that afflicted the old architecture in terms of performance and capability. So improve the performance and capability of the old architecture, we use the new architecture. So here is the diagram of the React Native new architecture. So here few things we have also discussed in my previous lecture of the old architecture. In few minutes ago we have also discussed React, JavaScript thread, shadow thread and native UI thread. So all these things also we used in new architecture. So here we just replace the bridge with JSI. So in few minutes we will discuss each part in detail. So starting from version 0.68, React Native provides the new architecture which offer developer new capability for building highly performant and responsive app. So before the version of the React Native 0.68, we did not use the new architecture because before 0.68 we used the bridge for architecture of React Native. So here we use the JSI. So new architecture introduce a different layer known as JSI. So JSI actually a JavaScript interface as replacement for React Native bridge. JSI is a lightweight API to embed a JavaScript engine in a C++ application, and Fabric uses it to communicate between Fabric's C++ core and React. So actually JSI, this layer will allow the native world to directly communicate with JavaScript world, and entire synchronization of the JS thread and native module is now possible. The main point is that direct communication with the JavaScript world and entire synchronization of the JS and native thread is now possible. So it is the main point of the JSI. Advantages of the JSI that now JavaScript world and native world directly communicate with each other. So now with the help of the JSI, native method will be exposed to JavaScript via C++ host object, and JavaScript can hold a reference to these objects and can invoke the method directly using that reference. So unlike the bridge, the JSI will allow JavaScript code to hold a reference to native modules, and through the JSI, JavaScript can call methods on this reference directly. So friend, it means that now we are not using bridge. So unlike the bridge, so here JSI will hold the reference of the native module, and with the help of these reference, now JavaScript can call native method directly with the help of this reference. So it is the big advantages of the JSI that JavaScript code could communicate with native side directly from the JS thread. So friend, it means that JSI will enable use of other JavaScript engine, and it will allow for complete interoperability between the threads. So because in old React Native architecture only JavaScript engine we use, but here we use other JavaScript engine also in new architecture. So JSI will eliminate the need to serialize JSON message, and it will fix the congestion and synchronization issue on the bridge. So friend, it means that because in old architecture we use the JSON message to communication between the JavaScript thread and native thread. In all communication we send JSON message from JavaScript thread to bridge and bridge to native module. So now JSI will eliminate the need of the serialized JSON message. So the advantages of the JSI is that it is written in C++. So with the power of C++, React Native can target large number of systems like smart TVs, watches, its. So it is the big advantage of the JSI. So Fabric is React Native new rendering system. So actually Fabric is a conceptual evolution of the legacy render system. The core principles are to unify more render logic in C++ and improve interoperability with the host platform and to unlock new capability for React Native. So with the new rendering system, user interactions such as scrolling, gestures, it can be prioritized to be executed synchronously in the main thread or native thread, while other tasks such as API request will be executed asynchronously. So it is the main point of the Fabric. So here all work to be executed synchronously in the main thread or native thread. So the three phases of the Fabric render pipeline we use. So first is render phase, second is commit phase, and third is mount phase. So we use here three phases of Fabric render pipeline. So first is the initial phase. Suppose here we want to render the hello world. So this is the JavaScript code we use in React Native for displaying the message of hello world. So here we suppose we want to render the following code into React Native. So under the hood how it's work, so we will discuss here. So here is a diagram is showing that so the render phase, before React component can be displayed on the screen, they must first be rendered by React. The render phase is the initial phase of the rendering process. So in this phase, React execute product logic to create React element tree. So this is the React element tree here. So when the React execute product logic, we want to create in React Native. So first of all, React element tree is generated. So which consists of React element. A React element is a plain JavaScript object that describe what should appear on the application screen. So here suppose this is the plain JavaScript object, and here suppose we want to display the hello world message. So a React element is a plain JavaScript object that describe what should appear on the application screen. So in this code, suppose we want to display the hello world on the screen, so it's a plain JavaScript object. So when your app is run, React execute your code and create a React element tree in JavaScript. So first of all, React element tree is generated. So based on this tree, renderer create a React shadow tree in C++. So based on this tree here, React shadow tree. So this is the React shadow tree and this is React element tree. So first of all, when we run the app, so first of all, React element tree is generated, and so based on the React element tree, here React shadow tree is created, and this React shadow tree is in C++. New render shadow tree will be immutable and it will be shared between the JS and UI thread for allowing straight interaction from both ends. So actually a React shadow tree will be immutable and it will be shared between JS and UI thread for allowing straight interaction from both ends. So with the help of the Fabric, the rendering mechanism becomes more optimized and efficient as it will create a shadow tree directly in C++. So because this shadow tree we create in C++, so this improving interoperability with host platform. So here host platform can be any Android platform or can be any iOS platform. So after the React shadow tree is complete, the render trigger a commit of React element tree. So the commit phase consists of two operations, layout calculation and tree promotion. So layout calculation, this operation calculates the position and size of each React shadow node. So suppose this is the React shadow node, the commit phase will calculate the size and position of this React shadow node. So actually in React Native, this involves invoking yoga. To calculate require each React shadow node styles which originate from React element in JavaScript. So in commit phase, when invoking the yoga, so yoga actually calculate the React shadow node position and layer. So this actual calculation require each React shadow node style which originate from React element in JavaScript. And in last, we call the mount phase. So this is the phase in which React shadow tree, which contain the data from the layout calculation, is transformed into host view tree. So host view tree can be any Android, iOS and other platform with rendered pixel on the screen. So actually after the late calculation, so here we are generating the host view tree. So actually what is showing on the screen, so mount face actually based on what we want to show on the screen. So all the structure and view of the late calculation we are showing here in mount face. So actually it transforms into host view tree, so which we want to show on the Android or iOS and other platform. So this is the mount face. So the fabric renderer create a corresponding host view for each React shadow node and mount it on the screen. So it means that, and based on the React shadow node, a host view is generated and mount it on the screen. So suppose here a complete example of the three phases of the fabric. For three phases of fabric render pipeline is showing here. Suppose this is the code we want to show on the screen. So here is a code here. So first of all, in React we are creating a React element tree. So this is the React element tree. So based on this React element tree, React Native create a React shadow tree. So this is a React shadow tree, and based on this React shadow tree here a host view is created. So this is the host view which we want to show on the screen. So actually this process of the React Native work under the hood. So actually this is the implementation of React Native, actually how it works under the hood. So next is turbo module. This is, we have discussed here JSI fabric, so now is turbo module. Turbo module are the old native module with new implementation and behavior. So turbo module are basically an enhancement over this old native module. So actually the turbo module is actually a enhancement over these old native modules. So this is the best feature of the turbo module, is that they are lazy loaded. In other words, it means that JavaScript code will only load it each module as needed and maintain a explicit reference to it. So it means that JavaScript code will only load it each module as needed. So this is the significant improved startup time for React Native app. So actually with the help of the turbo module, it improves that startup time, because when the each module needed, so then it's loads, so it improves the performance and startup time of React Native app. So next thing is code generation. So this point is also new. Static type and code generation is also new in React Native new architecture. So this is the another practical component of React Native design. Actually JavaScript is a dynamically typed language and JSI is written in C++. We have already discussed about it. So which is statically typed language. So actually JSI is written in C++ and it is a statically typed language. So consequently there is a need to ensure smooth communication between the two. For the smooth communication between the JSI and JavaScript, we use the static types. So because JavaScript is dynamically typed language and JSI is actually already written in C++, so for the better communication between the both, we use the static types. So that's why the new architecture will also include a static type checker called CodeGen. So for the better communication between the JSI and JavaScript, because JavaScript is a dynamically typed language and JSI is already written in C++, so for the better communication between the both, we use static type. So it's also called CodeGen. So I hope this video is very helpful for understanding the React Native new architecture. So if you like this video, please like, share and subscribe the channel. Thanks for watching.